So in this video, we're going to evaluate the given integral by changing to polar coordinates. So we have this double integral here, and we want to integrate over the region D, where D is the top half of the disk with center at the origin and radius 2. So here we have our double integral, and over the region D, x squared y dA. And remember, dA is dx dy if it's in this rectangular form, or dy dx. But what we want to do is we want to convert it to polar coordinates, so it'll be r dr d theta. So how do we convert? Well, the way we convert is not just by converting our x and y, but it's also by looking at our region and thinking about our region in polar. So we can't think about, well, it's hard for us to think about our region in rectangular when it's not something that is like a rectangle, obviously. And so we would convert it to polar and think about it in terms of polar. So we're thinking about this circle, the top half of this circle, or disk, I should say, with a center at origin and radius of 2. So center is going to be at the origin here, and then the radius is going to be 2. So this is 2, and there's 2 over here, and then there's negative 2. So the radius is 2. And that's all we need, because we can now form our circle, or semicircle disk here. And this is basically our region, where basically what we're doing is we're taking this region and we're finding the volume, essentially, of not this region, right? Not the area of this region, but the volume by thinking about the volume under the surface, x squared y, that is above this specific region. So the surface might go all of these different regions, but we're only thinking about this specific circle, semicircle region, and we're finding the volume that's above this region below the surface. That's what we're doing. That's the problem. Okay, so how do we find the region? How do we express it using this double integral notation? So the way we do that is, remember, the outer portion, right? The outer portion of the outer integral is always going to be our angle. It's going to be theta. It's not going to be r, because theta is what's the constant, and the constant has to always go on the outer integral. Remember that. So the outer integral is going to be theta. So theta equals something. You can just write that out if you want to. I typically don't, but you can write it out. And remember, we're going from theta equals something to theta equals something else. Think about like a sector or something going from one angle to the next. So we're starting at angle 0 here, and then we're going to pi over 2. This is pi over 2, and then this is pi, and then 3 pi over 2. I'll not label this because it's not important, but then 2 pi. So we're going from 0 to pi. That's what we're going to. 0 to pi. That's basically our angle. This was not too hard, right? So 0 to pi. So that's basically what we have for theta, 0 to pi. It's not anything complicated. Even r is not that complicated, really. So what we like to do with r is basically we like to think about the radii that we have, and we have two separate quantities that we need to put here. And what we like to think about is, so if we start at the origin and we draw a line like this, when we first enter our region, when do we first enter our region? Well, when we're entering our region, we first enter our region, we enter it immediately. And so that's why our r is going to be 0. That's when we enter it. We enter it immediately. And then as we keep on going, we end our region, essentially. Our outer bound is basically at this value of r. And this value is r equals to 2, because our radius is 2. So r equals to 2. So we're going from r equals to 0, which is what we saw immediately, and then r is equal to 2. So 0 to 2. That's basically it. It's not hard at all. So I'm going to remove this just because I didn't include it for the r. So let's be equal here, 0 to pi and 0 to 2. It's really easy. And then what we want to do is we want to convert. Now we have to convert this. We can't just write x squared y, obviously. So how do we convert this? Let's take this as a separate problem, x squared y. Remember, we have to use our equations. Remember that we can convert using a couple of equations, and two of them is that x is equal to r cosine theta, and y is equal to r sine theta. This is not too hard. Should be relatively intuitive. And if we just kind of substitute this in, we have r cosine theta squared, and then y squared, just y, so r sine theta. And so that gives you r squared cosine squared theta times r sine theta, which of course is just r cubed sine theta cosine cubed theta. Sorry, cosine squared theta. R cubed cosine squared theta. That's it. Now remember that this is what goes in here. So r cubed sine theta cosine squared theta. But that's not it, because dA is r dr d theta. So r dr d theta. And remember, theta has to go in the end because that's what's the outer integral. Remember to add that r, though. It's very important. Now we can go ahead and simplify our integrand. What's inside our integrand here? So we have 0 to pi and then 0 to 2. And this becomes r to the 4th power. So 3 plus 1 is 4. Sine theta cosine squared theta dr d theta. Okay, now let's think about this problem here. This is not too hard. Don't make it overly complicated. Just think about, well, there's two ways you can do this. I'll only do it in one way. I don't want to confuse you. Let's just think about this inner portion here, this inner region. So basically what we can do is we can take this inner region and we'll do 0 to 2 r to the 4th sine theta and then cosine squared theta dr d theta. So what we're doing is, whoops, we don't need dr d theta, we only dr. So what we're doing is we're only going to integrate with respect to r, so we don't need to worry about sine theta and cosine squared theta because they're constants. We can actually bring them out. And that's leads into the second way that I'm talking about. I won't do it in this way, but I'll just mention it. What we could have done is, since this is a constant, we can bring it out there. And then remember that all we're doing is we're integrating with respect to r for r to the 4th power. And since we're going to integrate, we're going to get a constant, we can actually bring this whole thing, once we bring this out, obviously, we can bring this whole thing outside. So essentially, we're going to be multiplying the integral of, so I'll write it out because it's hard to imagine that. So we're going to, this thing is equivalent to the integral 0 to pi, and then we can bring the r to the, the sine theta cosine squared theta out. So it's going to be sine theta cosine squared theta out, and then d theta, and then multiply that by 0 to 2 r to the 4th dr. Remember that this is equivalent to all that, but this is a way you can think about it, but I just didn't want to say it in this way because it could get confusing. Only when you're multiplying like this you can do that, but you can't do it all the time. Just remember that. So just try to, you can think about it in this way because this way is going to get you to the right answer regardless. So that's why I didn't want to confuse you. But if you want to do it in this way, it's also a potential way that you can think about doing it. Okay, we're integrating with respect to r. We're leaving our theta as a constant. So we can leave it as a constant. We can bring it out. So it's going to be sine theta cosine squared theta is and then integral 0 to 2 and then r to the 4th dr. So we can scroll down a little bit, and this is going to get you to sine theta cosine squared theta, and we have r to the 5th divided by 5, and then 2, 0. Sine theta cosine squared theta, we have, well, they can bring a 5 1/5 out, and that's 5. And so really it's just 2 to the 5th power, because 0 to the 5th power is 0. So I'll just include it just because. So what is 2 to the 5th power? That's 2 times 2 times 2 times 2 times 2, 4, 4, 2, 32, right? 16, 32. It's just a quick way you can do that. That's 32 though. So this is just 32 cosine squared theta sine theta over 5. Nothing complicated. Very easy integration here. Now let's go back and let's take all of this and let's move it back into our integral here. So what we can do is we can replace all of this with this. So it's going to be equal to 0 pi, and then we have 32 over 5 cosine squared theta sine theta dr d theta. Okay, is this hard? No, because we can take our 32 over 5 out and integrate from 0 to pi. We have cosine squared theta sine theta dr d theta. Okay, I keep saying dr d theta, and that's not correct. My bad. This is just d theta. This is just d theta. I just look at this top portion and I'm writing it again and again. It's d theta because remember we first took this portion and we solved it there, and so we replaced all of that with this, and so just d theta. Sorry about that. That's confusing when you're first learning it. So yeah, just ignore that dr. It's just d theta. Okay, now we can use what can we do? Well, let's think. We can do a u sub. It's quite easy to do u sub actually, because if we set u equal to, for example, let's see, cosine theta, we can set du equal to negative sine theta d theta, because remember, derivative of cosine is negative sine. And the reason why I didn't do du equals to sine is because obviously if I did du, that would be cosine, and then I'd still have a cosine left over. So you want to do the other one. So you want to do cosine as u. Okay. Now this is just going to be integral. Now u is cosine theta. What is cosine of 0? And I like to draw a unit circle, even if it's an easy one, just because it's sometimes confusing. So if we have, this is angle 0. So if we have cosine of 0, which is the x value, that's the x value of 1. So cosine of 0 is 1. Cosine of pi, we're going up to pi here, and so cosine of pi is x value is negative 1. So we have 1 to negative 1. Obviously we can swap these around if we need to, which we will, but and make this negative, which we will. So we'll do that. So negative sine theta d theta, and that's why we have our, well, that's not why we have our negative, but we have a negative here, so it works out for us. So we can add our negative in here, and then we have negative sine theta d theta. So that's, we're adding a negative in here and then negative outside, just so it's, we're not just adding a negative without changing anything. So negative, negative, positive. So negative sine theta d theta is du, and then we have u squared. It's just some basic integration. It's not hard. I don't want you to think it's hard, but this is easy. So this is 32 over 5, and then negative 1 to 1 u squared du, and then this becomes, so I'll try to speed it up here, 32 over 5 u cubed over 3, and then 1 negative 1, so that's 32 over 15 1 cubed minus negative 1 cubed, which becomes 32 over 15, and then 1 cubed is 1, minus negative 1 cubed is negative 1, so it's 1 minus negative 1, which is 2. Okay, so 32 times 2 is 64 over 15. Can this be simplified? Let's see. I don't think it can. 2, 3, 6, 4, 5. No, no, that can't be simplified. No, that's about how much we can do. And this is actually your answer right here. This is your answer. What this represents, I want you to know, is the volume of the figure that is above this region, below the surface that we have when we plot z equals x squared y. And since it's a circular, it's not like a rectangle. We used polar region. We used a polar coordinates to solve our problem. That's why. So that's the problem. I'll do more of these problems. They're very fun to do. I'll do more of them in future videos.